Hello, pre-calculus students and seekers of general truths. Let us start this lesson off with a bit of what I would consider a warm-up problem here. The following points are given in polar coordinates, and remember, polar coordinates are given in r and theta. Theta is how far we are going to rotate, and r is the radius of rotation. Find the distance between them. So let me just start out by sketching out these points here. So if we have an XY coordinate plane, our first point here, 530, would be like right here, you know, by a little bit of estimation here. So you go out 5, this angle here is 30 degrees, right? And then in XY, in rectangular coordinates, to find the exact location of this point isn't too hard. It's going to be r times cosine theta. So this is going to be 5 times the cosine of 30, and then r times the sine of theta. So it's going to be 5 times the sine of 30. Right, so that's going to give us 30 degrees here. That's going to give us the rectangular coordinates for this location, for this point. The second point, Q8, 125, so the radius is going to, let me mark this here, this is 5, right, that length there's 5. Q8, 125, 125 is probably like about here, and I'm estimating here. Okay, so this point here is P, this point over here is Q, up there, and this angle of rotation this time is 125 degrees. Okay, and because we are going from the standard position, let me say that on this radius here is 8. Because we are going from the standard position, we can also find the rectangular coordinates of Q in the same way. So let's just talk about on the side here, rectangular coordinates. Okay. For P, it is going to be 5 cosine 30 and 5 sine of 30. For Q, it is going to be 8 cosine of 125 and 8 sine of 125 degrees. All right. And then if we want to find the distance between them, right, we can use what we know is the distance formula. And I want to say that the distance formula is nothing more than the Pythagorean theorem. So the distance, this line, this red line right here, is going to be, let me remind everybody, it is the distance, d squared, is equal to x1 minus x2 quantity squared plus y1 minus y2 quantity squared. Okay, so using the distance formula, we can just punch all of this information into a calculator and get our answer. So let's do that. D squared, x1 here is going to be 5 cosine of 30. X2 here is going to be 8 cosine of 125. And all of that is going to get squared. Plus y1, which is 5 sine of 30. Plus, minus y2, which is 8 sine of 125. Okay. And if you're not familiar with the distance formula, go back and look at some of the notes in geometry on this. And then I'm just going to, oh, I forgot a square right here. This should be squared. Okay. So I'm going to put this all into a calculator and then crunch out the numbers. All right, so once I do all of that, I get that d squared is equal to 161.504623, and then I take the square root of that, and I get that the distance between these 2 points is approximately 12.700. But we can round it to 12.7. All right, so there we have it, a very quick warm-up here to what the rest of the lesson really is about. I'm going to end this video here and start another one where we sort of generalize this process.